We're told that the number 27,000,001 has four prime factors. We want to work out what those are. Now, of course, we're not allowed to use a calculator. That would be pretty boring and not very exciting. How can we do this? There's a bunch of ways we could do this. We could try and find a prime factor and divide through by this and rinse and repeat that process. But that's not super exciting. It would be kind of cumbersome and also wouldn't make for a very entertaining YouTube video. What am I going to do instead? I'm going to make a nice observation that this problem, or this number, sorry, is one more than 27 million. So if I write this as 27 million plus one. Okay, what's so useful about this? Well, 27 is a cube number, so is a million. So that means that 27 times a million must also be a cube number. 27 is 3 cubed, a million is 100 cubed, so therefore this number here must be 300 cubed plus 1, and 1 is the same as 1 cubed. Great, okay, cool. Now we can think about x cubed plus y cubed. X cubed plus y cubed, we can factorize that. That's the same as x plus y times x squared minus xy plus y squared. So if you've not seen this before, you can just kind of expand that to verify this. This kind of comes, from the factor theorem or the difference of two cubes formula, except now replacing y with minus y. A bunch of ways to come up with this formula. But if you've not seen this before, you can just check by expanding it that it works. Cool. So this is 300 cubed plus 1 cubed. So if we sub that into this formula, so x is 300, y is 1, this will be 301 times 300 squared minus 300 times 1, which is 300, plus 1 squared, which is 1. Okay, cool. So we've got 27,000,001 written as 301 times something. Okay, 301 is a manageable number. That's small enough for us for it to either be prime and us to check its prime or to find its prime factors. It's not too difficult to check that 7 is a factor of 301, and it's precisely 7 times 43. So this is going to be 7 times 43 times this number here, 300 squared, minus 300 plus 1. Now, 7 and 43 are primes. So because 27,000,001 has four prime factors, that suggests that this guy here is the product of two primes. The question is which primes, and you could try and just expand this out and work out what this is. So 300 squared, that's going to be what, 9,000 minus 300, 8,700 plus 1, 8,701, which is a pretty big number. I don't want to find two primes that multiply to give me 8,701. I'll be here all day. So we need to have a way to try and factorize this as it is. Can we do that? Well, it takes a little bit of spotting here, but the trick here I'm going to do is I'm going to try and make this thing here. I've got 300 squared, 1 squared. So if I had a 600 in the middle, that would make this 300 plus 1 squared. So I'm going to write this as 300 squared plus 600 plus 1 squared. So I've just randomly added a 600 in the middle. Then I've got to subtract off that 600, and I've still got this minus 300 here, like so. So 7 times 43 times, now this thing here is 301 squared, like so. In fact, I don't really need those brackets there, so just 301 squared. And what about this? This is minus 600 minus 300, so minus 900. You'll probably see where this is going. This is 7 times 43. I've got 301 squared there. 900, very conveniently, is 30 squared. So this is going to be 7 times 43 times 301 squared minus 30 squared. This is the difference of two squares. So this is 7 times 43 times, so 301 plus 30, 301 minus 30, and that's going to be 7 times 43. 301 plus 30 is 331, and 301 minus 30 is 271. And if you want to, you can check those are both primes, but those are indeed primes. And therefore, we've worked out the four prime numbers which multiply to give us 27,000,001.